Hello and welcome to Thuma Mina Teaching. This is your first grade 9 mathematics lesson of term 1. Today we will be focusing on the number systems. I am Lisa Sorrell and this is my Thuma Mina Teaching. Firstly, let's have a look at real numbers. Real numbers consist out of rational numbers and irrational numbers. And if we want to define rational numbers, we can say it's a number that has to be written in the format of a over b, where b is not allowed to be equal to 0. If b is equal to 0, then the number is undefined. It does not exist. Also, the number can be a recurring decimal. So, for instance, if we took the number 0,333, never ending, then we can see there's a fixed pattern because the number 3 repeats every time, so there's a fixed pattern. The number can be a finite decimal number. So for instance, if I look at a half can be written as 0,5, and that's it. It doesn't go any further. It just stops over there. Therefore, we can say that is also a property of rational numbers. Let's look at a few examples. For instance, the number 10. The number 10 can be written as 10 over 1. It's still 10 because 10 divided by 1 is 10, but it's written as a fraction. Now, the value of minus 20,500, can that be written as a fraction? Yes, we can write it as minus 20,500 over 1. Therefore, it is a rational number. If we have a look at 3 over 7, now it's very clear that 3 over 7 is already in the form of a over b, and thus we can say it is a rational number. As previously stated, when we look at the value 0,3, and that little dot on the top of the number actually indicates that this value is recurring. In other words, the value is 0,3333, and this is never ending. Therefore, we can say this is a rational number. Rational numbers are numbers that consist out of natural numbers, whole numbers, integers, and fractions. So if we have a closer look at natural numbers, it starts from the value 1, 2, 3, 4 till infinity, but it does not include fractions. When we look at whole numbers start from 0, 1, 2, 3 till infinity. And when I use the word infinity, it means it's never ending. So it could go up to 1 million, up to 2 million, but it does not include fractions. Integers is all the numbers that is greater than 0, for instance, 1, 2, 3, 4, 5, till infinity. And also, if we look at values that is smaller than 0, like minus 1, minus 2, minus 3, that is also part of the integer number system. Now, a practical example of an integer would be temperature. So, if we think of a really cold day, we perhaps would say it's minus 7 degrees Celsius. So we need integers to indicate the negative number system. Fractions are also part of rational numbers. And remember, we rewrote all our whole numbers or natural numbers or integers as a fraction to indicate that it's a rational number. Practical examples of fraction would be a half, 13 over 7, and minus 3 and 5 over 22. Now let's have a look at irrational numbers. Irrational numbers are numbers that cannot be written in the form of a over b. In other words, it cannot be written as a fraction. It is a non-repeating, never-ending decimal. The example we used in the previous slide when we spoke about rational numbers, we used 0,333, which was never-ending. But if we think of a value, for instance, 0,12571350009, I can go on forever, but there's no fixed pattern. And therefore, I will know that that is not a rational number, but an irrational number. Let's look at a few examples. The most common example used to explain an irrational number would be pi. I know some of you might think that pi is the value 22 over 7, and then one could argue that that is a fraction, and therefore it should be a rational number. But that is a common mistake, merely because 22 over 7 is the closest ratio we have to pi, but it's not the precise value. So quickly grab your calculator and type in the value of pi. The answer should be 3,14159,265. It is clear that there is no fixed pattern. It doesn't end, it's never ending. Therefore, this is an irrational number. If we look at the second example there, 12,457,80121113,471, it is clear that there is no fixed pattern, it's never ending, therefore irrational number. If we look at the cube root of 2, one should ask yourself the following. What times itself 3 times could give you the answer of 2? Now, if we quickly test the value 1 multiplied by 1 multiplied by 1, the answer is 1. If we look at 2 multiplied by 2 multiplied by 2, then the answer is 8. So there's not an integer that could be multiplied by itself 3 times to give you the answer of 2. Let's check what our calculator says is the value of the cube root of 2. The answer is 1,2599210. Therefore, it's clear that even though on your screen, your calculator screen, it might seem to you that the number is ending, but this number is continuous, and the amount of numbers indicated on your screen is limited. Therefore, it is clear. This number, there's no fixed pattern. It is never ending. Thus, it is a irrational number. And the same argument can be made when we look at the square root of 7. So you can type that up in your calculator. You should get an answer of 2,645751311. Therefore, it's clear, no fixed pattern, never ending, thus the number is a irrational number. Imaginary numbers and non-real numbers. That is precisely the same thing. It's just a different wording. Now, imaginary numbers or non-real numbers cannot be indicated on the number line. Let's have a look at the following example. The square root of minus 10. Now, the first thing you should ask yourself, if I multiply a positive and a positive number with each other, then it would give me a positive answer. The same would be if I multiplied a negative value with a negative value, it would also give me a positive number. So therefore, there is not an identical number that can be multiplied by himself to give you an answer of minus 10 or minus anything. Let's test quickly. Type the square root of minus 10 in your calculator. Immediately you will see that your calculator would give you an answer of math error or just error. Therefore, it is clear that the square root of minus 10 is a non-real number. So if we look, for instance, at the sixth root of minus 50, there is no value that can be multiplied by itself 6 times to give you a negative answer. Therefore, we can argue that the sixth root of minus 50 is also a non-real number. Lastly, minus 3 to the power of a half. Now, if we have a look at exponents, and some of you might remember this from grade 8, also later this term, we also have a look at exponents. We can actually rewrite minus 3 to the power of a half in the form of the square root of minus 3. Now, the square root of minus 3, there is no value that can be multiplied by itself to give you minus 3. Therefore, the square root of minus 3 is a non-real number. So if we want to give you a bit of a visual perspective, you could actually say that we've got real numbers and then imaginary numbers or non-real numbers. Real numbers consist of rational and irrational numbers, also out of integers and fractions. And integers consist of natural numbers and whole numbers. Now let's have a look at the following examples. Example 1. Show that the following numbers are either rational or irrational numbers. So firstly, we know that a value is a rational number if it can be written in the form of a over b. Now, can I write the value of 8 as a fraction? Yes. We could say that it's 8 over 1, because 8 divided by 1 stays 8. Therefore, we can say that the value of 8 is a rational number. If we had to take the value of 0.75, now some of you might recognize this value, but if you're uncertain, go and rewrite it as a fraction. So I could write it as the value of 75 over 100. Clearly that is a fraction, but you could go and simplify it a bit further. The value of 25 can be divided into your numerator and your denominator, and it can be simplified and be written as 3 over 4. Is 3 over 4 in the form of a over b? Yes. Therefore, it is clear that this is a rational number. Number 3. Now, don't be fooled with the value of 0. Can 0 be written as a fraction? Well, 0 can be written as 0 over 1. You could even write it as 0 over 50, because 0 divided by anything is always 0. But it is clear it can be written as a fraction. Therefore, we can say that 0 is a rational number. Number 4, when we look at number 4, it's pi over minus 2. Now, I would be very careful with this because they're actually trying to trick you a little bit. It might seem to you that it's written in the form of a over b. But let's go and test this, because we know that pi is an irrational number. And what happens to pi when we divide by 2? Go and type that in your calculator. You should get an answer of minus 1,57079632. It is clear that there's no fixed pattern. It is never ending. Therefore, pi over minus 2 is an irrational number. If we have a look at number 5, we have the square root of 5. Now you can ask yourself, is there a value that can be multiplied by itself to give you 5? If I immediately think of the value of 2 times 2, that gives me 4, or 3 times 3, which gives me 9, there is no value that can be multiplied by itself to give you 5. Now the other alternative is to test this on your calculator. Now if you type that up, you should get a value of 2,23606797. It is clear that there's no fixed pattern. It is never ending. Therefore, this is an irrational number. If we have a look at number 6, which is the cube root of 27. Now here they're trying to make it a bit tricky. Merely because when I see the cube root of 27, you should ask yourself what multiply itself 3 times could give you a value of 27. So let's go and test. If I had to test 2 times 2 times 2, 2 times 2 is 4 times 2 is 8. Let's test the next value. 3 times 3 times 3. Now 3 times 3 is 9. 9 times 3 is 27. Therefore, we can calculate the cube root of 27, and it is 3. Now the question should be, is 3 a rational or an irrational number? Well, we can write 3 in the form of 3 over 1, which is a fraction. Therefore, I can say that the cube root of 27 is a rational number. Let's have a look at example 2. They say classify each of the numbers in the table below. Now, the first value is minus 6 over 7. The first question should be, does that value exist? Yes. So it's a real number, therefore it is not a non-real number. Is it a rational number? Yes, because it can be written in the form of A over B, therefore it is a rational number. If it's a rational number, then immediately it cannot be a irrational number. Now, we spoke about this previously. Integers, natural numbers, and whole numbers cannot be fractions. Therefore, minus 6 over 7 is not one of the three. Let's look at the value of 2,400. Is that a real number? Of course, it is a real number. Therefore, it cannot be a non-real number. The next question should be, can 2,400 be written as a fraction? Yes, I can write 2,400 as 2,400 over 1. Therefore, this is a rational number, and therefore it cannot be a irrational number. Now, is 2,400 an integer? Yes. Is it a natural number? Well, natural numbers start with the value of 1, 2, 3 until infinity. So therefore 2,400 is included in that. So it's a natural number. Is it a whole number? Yes. Whole numbers start from the value of 0, 1, 2, 3 till infinity. Now, we now have a look at the square root of minus 3. So you have to ask yourself, is there a value that I can multiply by itself to give me an answer of minus 3? No. So, therefore, the square root of minus 3 is a non-real number. If you remember the visual interpretation of the number system, we had real numbers, and then on the side that was not included by the real numbers was non-real numbers. Therefore, if a value is a non-real number, it will not be any of the other numbers. Now, let's have a look at 2 pi. It is clear that pi is notorious for being an irrational number, but you can always go and test it. So if you're uncertain, just go and type it in your calculator. The only circumstances where pi would not be an irrational number is when pi is multiplied by 0 or when pi is divided by itself. So let's have a look. If I type in 2 pi into my calculator, you should get an answer of 6,283185,307. It is clear that there is no fixed pattern. It is never ending, therefore it is an irrational number. And we also know that irrational numbers are part of the real number system, and if it's part of the real number system, it cannot be part of the non-real number system. Then, if it's an irrational number, it cannot be a rational number, and it cannot be a integer, natural number, or whole number. Let's have a look at the cube root of minus 8. Now, don't be fooled with a cube root where the value is smaller than 0. Because you should ask yourself, if I multiply a number by itself 3 times, could I get an answer that is negative? Let's test. For instance, if I take the value of minus 2, multiply minus 2, multiply minus 2. What is a minus 2 multiply a minus 2? It would give me an answer of 4. But what is 4 multiply negative 2? That gives me an answer of negative 8. Therefore, the cube root of minus 8 gives me an answer of minus 2. So it's always very important to see if you can simplify the number given. Now, so if I look at minus 2, is minus 2 a real number? Yes. If it's a real number, then immediately it cannot be a non-real number. The next question you should ask yourself, is it a rational or irrational number? Now, can minus 2 be written as a fraction? Well, I could write it as minus 2 over 1. Therefore, it is a rational number, and then it cannot be a irrational number. Now, an integer is a value that is smaller than 0 or greater than 0, but it is not a fraction. Now, is minus 2 smaller than 0? Yes. So therefore, it is a integer. But natural numbers start from the value of 1, 2, 3 till positive infinity. Therefore, minus 2 is not included here, and it's not a natural number. Is it a whole number? Well, whole numbers are values that start from 0, 1, 2, 3, up until positive infinity. Therefore, it is not a whole number. Let's evaluate the number minus 5. Is minus 5 a real number? Yes, it exists. Therefore, it cannot be a non-real number. Is it a rational number? Can I rewrite it in the form of a over b? Well, of course, we could write it as minus 5 over 1. Therefore, it is a rational number, and therefore it cannot be an irrational number. Is it an integer? Well, it's smaller than 0, but it's not a fraction. Therefore, I can say it is an integer. Is it a natural number or whole number? Well, we know that natural numbers start from 1, 2, 3 till infinity, whole numbers from 0 till infinity, positive infinity. Therefore, it cannot be a natural or a whole number. Now, be careful when trying to solve the following question, where they ask us, what is pi over pi? Pi over pi can be simplified. Now, if I had to ask you what is 6 over 6, you would immediately tell me the answer is 1. Now, the same concept is used when we look at pi over pi, because it's the same value over the same value. So when we simplify that, it can be written as 1 over 1, or just 1. Therefore, this is a real number and not a non-real number, but it forms part of the rational number system because it was simplified and the answer is 1 and it is written as 1 over 1. Therefore, it is not a irrational number. Is it an integer? Well, we know that integers are values that are not fractions and it can be positive or negative. So it's an integer. Is it a natural number? Yes, of course, because natural numbers start from the value of 1. Is it a whole number? Yes, because whole numbers start from the value of 0, 1, 2, 3, up until infinity. I hope you enjoyed the lesson. In the description below, you'll find a link that gives you access to a Google slide and also to a self-marking assessment.